2, 1. So happy return. So proof of the derivative for basically a radical function. So here's our radical function, and we want to be able to show what the derivative is now. So here's the derivative. It's all of these are equivalent, so they're all the same. It just depends how you actually write it. So of course, I'm assuming that you are comfortable in going back and forth between radicals and fractional exponents. So if you ever forgotten about that, I'll put up a link up above there, okay, kind of how to go back and forth in between them. So for proving this derivative, so we're going to start from first principles in terms of the limit as h approaches to 0, okay, of the difference that we have. And I am going to use a particular, it's a little bit of a trick that we're going to need, so I'll talk about that as well. So first off, I'm going to take this and actually just simply write it in the form of x 1 over m. So I'll write it like this. It's going to be a little bit easier for me to write instead of the radical symbol on a continuous basis. Okay, so that's what I will have. And now if I take the original definition, so as h approaches to 0, and I start substituting back in, so x plus h 1 over m minus, and this is going to be x to the 1 over m all over h, right? So that's our standard definition that we would have to find. Now I'm assuming, so m is basically some positive integer. Okay, we'll assume that it's at least 2, okay, or 3 or 4 or 5 or etc. So we'll make that assumption. And now if I do this, what am I going to be utilizing? So I'm going to be dropping, let me just drop this for the moment, let me drop this for the moment. I'll just want to concentrate on the difference. All right, so before I jump into this, I would want you to be comfortable with the fact that if I have a minus b, now we can assume, so here's my a, let's say that this was my a, this is exactly what I'm going to be doing, and let's say this is my b. Okay, I just don't want to rewrite them. Now I can multiply this by, let's say let's say this will be m minus 1 plus a m minus 2 times b plus a m minus 3 b to the 2 plus, okay, and I would continue this pattern. So notice it's going m minus 1, m minus 2, m minus 3, so on. It's going to go all the way down to eventually, a to the 2, and then it's going to be b, and b is, notice it's going b1, b to the 2, b to the 3, and so on. So we would have had, okay, within here, so this would have been m minus 3 plus a to the 1, b m minus 2, plus, and then I'm running out of space here, but I'll just put, this is going to be b m minus 1, all right, and I'll put the bracket as so. Now you might say, what the heck is this? Why are you multiplying by this? Well, the reason why I'm multiplying by this, this is actually understanding the difference of the nth degree. So if you recall, difference of squares, difference of cubes, so if you do that, probably somewhere in around grade 9, maybe 10, maybe grade 11, you use that difference of squares and difference of cubes, and this is the general case, so this is the difference of the nth degree. All of this, if we would expand this out, this is just going to be a to the m minus b to the m. That's what I'm going to get. Now I'm going to need this little trick here, and you'll see why, because I want to be able to rationalize the numerator, okay, within here. That's what I want to be able to do. I don't want to be dealing with radicals there the way that they are, because I'm going to get indeterminate forms in my limit. Now, All of this I actually talk about and I prove with regards to these difference of squares, difference of cubes, and the difference of the nth degree. I'll put up a link up above there. I did a video on that at some point. So you can look at that because I'm going to need this particular trick. So now that I just kind of gave out or gave away that I'm going to be using this trick, so let me copy this. So I'm going to copy it, bring it down. Okay, so paste it within here, and I just want to show you what's going to happen to this. So I'm going to multiply this entire thing. Now, of course, okay, so this is over h. So I'm going to be multiplying this by, okay, now if I want to multiply this without changing, so I have to multiply the numerator and denominator by the same thing. So what I'm going to do is I'm going to be multiplying it by, okay, and I'm going to be doing exactly this in here. So just think of the a. Let me just change the color here. This is going to be a little bit tricky because I'm running out of space here. But, okay, so I'll give it a try. So I have x plus h, right, 1 over m. That's my a. This is my a. All right, so I want to have this whole thing. And now I'm going to put this whole thing in bracket and then, you know, raise it to the m minus 1. So hopefully you can see that this is what I'm doing. Now I'm going to do the same thing. So I'm going to multiply by plus. And now this is going to be this entire thing. So this is my a. I'm going to duplicate it, right? Now this is going to be m minus 2. So that's this right here. And then I still have to multiply by this b. By now my b, okay, within here is just x 1 minus m, right, to the 1 plus. And of course I would put, you know, dot, 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 okay. I would finish this entire thing off. You know, so I would do this, okay, this, you know, so eventually, okay, what I will have, because this is gonna kind of look a little bit, let me duplicate this. Okay, so this is now, I'm gonna cheat. I don't want to write all of these. So I'm gonna be now, you know, I'm right here, all the way right here, dot, dot, dot. So this is to the 1. And then I have my x 1 over m. And this is gonna be m minus 2 plus, and notice again, I'm just running out of space here because this is just, you know, it's annoying to do this. So x 1 minus m, and then this is going to be to the m minus 1. All right, so now I have, so this is my entire bracket in here. That's the numerator. Okay, so this whole thing is being multiplied by this. But of course, I can't just multiply the numerator because then I'm going to be changing my whole fraction, right? Like I would have changed this thing. It's not equal to it. So I have to be dividing by the same thing, right? So now I have to take this, okay, and also divide it by that. So I'm going to, you know, so if I divide it by this, right? So the numerators and denominators, that's really just multiplying by 1, right? Now, what that allows me to do is now it allows me to take this and multiply it by this entire chunk right here. So I'm doing really this, okay? So this multiplied by the entire chunk over here. Now we know what that gives us. That gives us this, okay? So that's going to be my numerator. Now, okay, let me just zoom out in here. So if I would do that, then that's going to be equal to x plus h 1 over m, all right, to the m minus x 1 over m to the m. That's in my numerator. That entire thing would equal that. And so that is just directly coming from the difference of the nth degree here. So I'm using that little trick in there. But if you notice, if I bring this inside over here, 1 over m times m, well, that's just going to be m over m, which is 1. So this very nicely breaks down into h plus x minus just x. And hey, I know what that is. X minus the x is just going to be h. And that's all that I have left in the numerator by doing, this little trick here, by multiplying by that. Now you will say, okay, that's nice, but you still have, you still have your h in the numerator, and you still have this entire thing because you multiplied both the numerator and the denominator, okay, by all of this whole thing, this junk. So that is true, right? So what I have is, in the numerator, I only have h left. In the denominator, I have the h, and I have that whole junk there, okay, that I had. So all of this, let me bring it down here. So all of this still in the denominator, sorry. So I'm going to take that, I'll duplicate it, I'll bring it in here. But it actually doesn't cause us any problems as we take the limit. So this will cancel, right? So that's fine. Now, as I take this, I'm going to make this a little bit smaller. I am taking the limit as h is approaching to 0. So those h's will cancel. So that means I have 1 over this whole thing in here. That's what I would have. Fine. Okay, so if I have that, now this right here, okay, so what is this equal to as I bring in the limit inside of there? Well, that h tends towards 0, so it's basically 0. So what I will get is, okay, so that, so this term right here is equal to h tends towards 0. So this is just x, okay? Notice this is going to be to the 1 over m minus 1. So that's that term. Now this particular term right here, so it's going to be plus. Now that's going to be, again, so that h tends towards 0. So that's x to the 1 over m, right? This is m minus 2 multiplied by x 1 over m to the 1. So that's that term plus, dot, dot, dot. Okay, so all of these particular terms that I have, so even if I do this one, then again, that one is would have been in here. That's going to be x, okay, right there, to the 1 over m to the 1, multiplied by x, 1 over m to the m minus 2. And then the last term, this one, well, that one is going to be exactly, okay, so notice, so it's going to be x 1 over m, and then m minus 1. So it's a lot of massaging, but these, right, they have the same base of x to the 1 over m. So I can just add the exponents in here. So this exponent plus 1. So what happens that all of these terms, right, if I would bring this inside of here, I'm going to get x m minus 1 over m, right, plus, and then again, okay, this is going to be x, right, 1 over m, okay, so this is going to be, let me just show it to you just so that you can see. So this is what's happening in here, right? But this is, so, so these two are added. So this is just x. And again, I'm going to get m minus 1 over m plus and dot, dot, dot. So I have all of these are the same. Again, if I bring this in here, so this is going to be x m minus 1 over m. So what do you notice? They're all the same, right? So I can just add them all together. Now, how many of these terms do I have in this thing? Well, how many of them do I have? You can see in here, okay? So notice it goes from, okay? So I'm going to go kind of from the second term. So notice it was going from 1. Now this would have been 2, 3, 4, 5, all the way up to m minus 1 plus the first term. So plus the first term, which is this one. So I have actually m terms here. I have m of these. So I have m of these. So all of this is just equal to m times x to the m minus 1 all over m, right? That's my denominator. Now, if you go back to the original limit, well, you know, we had h over h, so that's 1 all over all of this, which is what I just simplified. So this is going to be 1 all over m, and this is x, okay, m minus 1 all over m, which is exactly our derivative. But this is what we wanted. Okay, so this is nothing else. Now, if I bring this up to the numerator using the exponent, rules, I would get 1 all over m. Okay, so that's fine. Then if this would have gotten up to the top, this is just x minus m minus 1 over m. And that is, if you massage this out, okay, within here, so that's x. Okay, so notice negative m plus 1, okay, all over m. Okay, this is going to be over m, like so. So, if I go all the way back here, was this exactly what we had? Well, okay, so notice this is indeed what we had. 1 over m, x to the negative m minus 1 m, okay, or you can write it, like this or like this, which certainly within here, so if you were stuck from this point, so if I had that, indeed, this is equal to 1 all over m, okay, m, the root of x to the m minus 1, which is indeed the derivative. So a lot of work, and we needed this particular trick to be able to solve it. So we needed this trick, which is really just understanding and being comfortable with the difference of the nth degree, like difference of squares, difference of cubes. You can always use that to be able to actually rationalize completely your numerator with these radicals. So that's pretty cool. So there you have it. That is the proof for doing, okay, the derivative of a radical. Okay, thanks for watching. See you in a future video. Bye, everybody.